All right, ladies and gentlemen, this video is going to continue the notes over Chapter 4, Section 1, which is reviewing right triangle trigonometry as we learned it in our geometry courses. Again, the idea here is that we should already know this information, but it has probably been at least a year and a half to 2 years since the last time you did anything with it, so we need to make sure that we're solid on our SOHCAHTOA and our right triangle trigonometry. Just to remind you what we did in the last video, we were discussing how we use SOHCAHTOA to find missing side lengths in right triangles. So here in example 4, we're asked to solve for x. So once again, we have here a right angle. And based on that right angle, we ask ourselves, okay, if I'm working with my 33-degree angle, which two sides am I working with? Well, the x is opposite the right angle, which makes it the hypotenuse. And the 12 is next to the 33-degree angle, but it's not the hypotenuse, which makes it the adjacent side. Again, the main reason we're doing this, naming these sides, is so that we can figure out which of our three trig functions we should be using. Sine, which relates opposite to a hypotenuse, cosine, which relates adjacent to a hypotenuse, and tangent, which relates opposite to adjacent. SOHCAHTOA. Sine's opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent is opposite over adjacent. So if we're working with adjacent and hypotenuse, this is a cosine problem. So we would choose cosine and we would go in and write an equation. The cosine of our angle, 33 degrees, equals adjacent over hypotenuse. Now we saw an example of this in the previous video when the variable's in the denominator. That is a two-step equation to solve. Step 1, we multiply both sides of the equation by x to eliminate the fraction, which would give us x times the cosine of 33 degrees equals 12. And then we would divide by the cosine of 33 degrees. When we do that, that gives us x by itself. X is 12 divided by the cosine of 33 degrees, and we feed it to our calculator. 12 divided by, we hit the cosine button and type in 33. We're looking at 14.30. Now the directions at the beginning of this section set around everything to the nearest tenth. So hopefully we all realize that a 0 means that we would round that 3 down or keep it the same, and we would come up with 14.3 units for our x value. Okay, so here this one's a little bit more advanced because we have two different variables to solve for, but again it's the same idea. Okay? We start off dealing with the 71-degree angle is the angle we're working with. Based on that, 15.1 is the hypotenuse, x is the opposite, and y is the adjacent. So we can't solve for x and y at the same time, which means we can't deal with both opposite and hypotenuse. So for x, we are going to relate the opposite and the hypotenuse, which means if we're looking at SOHCAHTOA to figure out which one to use, we are going to be using the sine function because sine is opposite over hypotenuse. That gives us the equation sine of x equals, that was not correct, sine of 71 degrees, sine of the angle equals opposite over hypotenuse. To get x by itself, all we need to do, because it's on the top of a fraction, is multiply both sides by the denominator of the fraction, which would give us x equals 15.1 times the sine of 71 degrees, and we're going to feed that to our calculator. 15.1 times the sine of 71 degrees is 14.27. Now again, that 7 would tell us to round our answer up to 14.3 units. Then for y, we would refocus our attention and relate the adjacent and the hypotenuse. So again, we would go and look at SOHCAHTOA, at least in our brain, and we would ask ourselves which of our three trig functions relates adjacent to hypotenuse. That would be cosine. And we would set up an equation. Cosine of 71 degrees equals adjacent, which is y, over hypotenuse, 15.1. This is the exact same work we did a second ago. We multiply each side by 15.1. And that gives us y equals 15.1 times the cosine of 71 degrees, which we feed to our calculator. Which gives us 4.91. Look at the 1, that tells us to round down to 4.9 units for our value of y. So hopefully by now we're becoming relatively comfortable solving for side lengths in right triangles. You should pause the video and try each of the next couple examples in your notes to see what you can come up with. Okay? Solve for the missing variables in each of the following equations. Those are kind of hard to see, but in your notes, hopefully it's easier to see the variables here. That's x, that's y. Okay? All right, so take some time, pause the video, try these examples, and then resume the video and you can see how you did. All right, folks, let's see how we did. First of all, this is a 43-degree angle here, if you can't read that. And this is a 28-degree angle here. And that does say 12 on that side right there, okay, as well as here. This also says 12. So, on part A, we have two variables to find. 12 is the hypotenuse, x is the opposite, y is the adjacent. So you should have written two equations. For x, you should have written the sine of 43 degrees equals x over 12, because sine would relate opposite to hypotenuse. We would multiply each side of that equation by 12, which would cancel the 12 out of the fraction and give us x is 12 times the sine of 43 degrees. We would feed that to the calculator. 12 sine 43, and that would give us 8.18, meaning we would round our answer to 8.2 units for x. For y, we would want to relate the adjacent to the hypotenuse, so we would write out a cosine equation. The cosine of 43 degrees equals y over 12. Otherwise, the work would be the same. We would still multiply both sides of that equation by 12. And that would give us that y is 12 times the cosine of 43 degrees. We would feed that to our calculator, 12 cosine 43, and we would get 8.77. So that would tell us to round our answer to 8.8 units. Again, if you haven't done so already, pause the video and try the other one on your own so that you can make sure you get some practice that's not just me walking you through the problem. Okay, so on part B, if we want to find x, we first need to figure out what our sides are. In this case, we know the opposite side, and we're trying to find the adjacent and the hypotenuse. So for x, we would need to relate opposite to adjacent, which means we're dealing with the tangent of 28 degrees. Which is opposite over adjacent. Again, to solve that, we need to get rid of the fractions. So we'd start by multiplying each side by x, which would give us x times the tangent of 28 degrees equals 12. And then, to get x completely by itself, we would divide by the tangent of 28 degrees. So we divide both sides by the tangent of 28 degrees. And we get x equals 12 divided by the tangent of 28, which we'd feed to our calculator. So 12 divided by the tangent of 28 degrees is 22.56, which would round up to 22.6 units. Then for y, separate out our workspace here. For y, we need to relate opposite to hypotenuse, which would be sine. So we'd say the sine of 28 degrees equals 12 over y. Otherwise, the work would basically be the same. The y is on the bottom of the fraction, so we do need to clear the fraction by multiplying each side by y. which would give us y times the sine of 28 degrees equals 12. And then we would divide each side by the sine of 28 degrees. And we get y is 12 divided by the sine of 28 degrees, which we're going to feed to our calculator. 12 divided by the sine of 28 is 25.56. So that 6 would have us round our answer up to 25.6 units. Okay, there are two more of these in your notes. We're going to do these two, and then we will stop the second video here and go on to a third. So these will be the last two examples on this video. Take a minute, try them, see if you can do them without my assistance. So, what we need to do first is, in order to find the sine, the cosine, and the tangent of one of these angles of A or C, we probably are going to need that last side. So what we need to do first is we need to figure out the missing side length. Let's call this side length C. You know what? No, let's call it B. Okay? Because what we need to do, we know the hypotenuse and we know one of the legs. So what we should do first is we should figure out the length of this third side by doing the Pythagorean Theorem. B squared plus 4 squared equals 5 squared. A squared plus B squared equals C squared, where C is the hypotenuse. So we solve that equation for B. Let's see, B squared plus 4 squared, which is 16, equals 5 squared, which is 25. Subtract 16 from each side of that equation. Gives us B squared equals 9. And then to get B by itself, we would need to take the square root, which means that this side is 3 units because B equals 3. From there, we should be able to write out fractions for sine of A and tangent of C relatively quickly. For angle A, the sine of A is opposite over hypotenuse, which would be 4 over 5. Because for angle A, 4 is the opposite, 5 is the hypotenuse. For tangent of angle C, we would set up opposite over adjacent, which would be 3 over 4. That would be it. That's all we got to do. Don't have to hit any buttons on the calculator. Don't need to turn anything into a decimal. Those answers are the correct values. On the other one, for triangle DOG, again, the first thing we should do is figure out the length of the hypotenuse. So in this case, 1 squared plus 1 squared equals C squared. The Pythagorean Theorem, where the hypotenuse is C. So 1 squared is 1, meaning we have 1 plus 1 equals C squared, or 2 equals C squared. Take the square root to get C by itself, which means that C is the square root of 2. It is very common in higher level trigonometry classes for us to have a reduced root for a side length. You are not to turn that into a decimal or round it off. So the square root of 2 is going to be our hypotenuse. Okay, so the cosine of angle G would be adjacent, which is 1, over hypotenuse, which is root 2. Now, we're not allowed to leave it like that. We have to do what's called rationalizing the denominator. So the cosine of G, which is currently 1 over the square root of 2, we have to fix that. That's not an acceptable way to leave it, because if you remember your algebra rules, you're not allowed to leave a square root in the denominator. So we multiply the bottom and the top of that fraction by the square root of 2. Now, that does not mean we're multiplying by root 2. What we're multiplying by, this red fraction here, is equivalent to 1, which means we're not changing the value, we are changing the notation. So the cosine of angle G would be 1 times the square root of 2, which is the square root of 2, over the square root of 2 times the square root of 2, which is the square root of 4, or 2. So the cosine of G would be root 2 over 2. Tangent of angle D would be opposite over adjacent, which is 1 over 1, or 1. That's it for the second video. There is still more information in these notes, so there will be a third. Please continue to the next video when you're ready. Thank you for your time.